6.4 linear terms. A simple situation in algebra is when we have a number multiplied by a variable. For example, here we have 4x, so that means the number 4 multiplied by whatever x is, so x represents a number, or 13y. So that's what a linear term looks like. So a linear term, it's just a number times a variable. So very simple. Just to see some more examples. So yeah, it could be any letter. So here the variable is w, so 2w. The number could be a fraction. This is 4/5 times x. Here's a more confusing one yet. We're dividing x by 3, but you could think of that as 1/3 times x. So that's a useful way to picture this, see this linear term. It's if you multiply 1/3 times x, it looks like this. The number could be negative. This is negative 6y. What happens if you don't see a number? Then there's really a 1 there. So this is just y, but this is a kind of a hidden 1. If you want to, it's useful to include the number. And for this last one, negative x. So the number in this case is negative 1. So this is really the same as negative 1 times x. So when you're combining linear terms together, yeah, you really want to see what the number is, include the number. For adding linear terms, we need to remember the distribution rule of arithmetic. So here we have a sum b plus c in parentheses, and it's multiplied by a. So this situation really means the a is multiplying the b and the c. And the same if you're multiplying on the right. So this c is multiplying the a and the b. So without parentheses, it's AC plus BC. Okay, so yeah, this distribution rule comes up all the time. This is what we need for combining like terms. So yeah, so just replacing the a, b, and c with 2, 3, and x. So 2 plus 3, that's 5. So this is really 5x on the left. But if you distribute, you can write it as 2x plus 3x. So really the distribution rule is telling us that for situations like this, where you're adding linear terms, so 2x plus 3x, you can add those together and you get 5x. Okay, this only works when you have the same letter, the same variable, and it ends up you just keep that letter, and all you're doing is you're adding the numbers here. And it makes sense, yeah. So 2x's plus 3x's, how many x's? 5 x's. And yeah, don't forget, so x just represents some unknown number. It could be 10, it could be 100, could be 13.63, so any number. So this certainly makes sense when x is 10. So 2 times 10 plus 3 times 10 equals 5 times 10. That looks good, but the point is it works for any, so x could be anything. Alright, so that's, yeah, it's just a fundamental idea in algebra, how to combine linear terms. And it works in general, but yeah, again, we have to be talking about the same variable. So here in example 1, simplify 12y plus 19y. And this time it's y's instead of x's, but it's the same idea. So 12y plus 19y is equal to 12 plus 19. Quantity, that many y's, and that's 31y. Example 2, we're back to x's. 3x minus 10x. So here, yeah, we have these two linear terms. We have a 3x and a minus 10x, and it's useful to, yeah, if we want to use our distribution rule, which is for addition. Just think of this in terms of addition. Yeah, it's 3x plus negative 10x. That's the same thing. So we have a 3 plus negative 10. We want to add those together, and that's negative 7. So negative 7x. Okay, so yeah, it's more confusing with negatives, but just when we were working with sign numbers, so subtracting 10 is the same as adding the opposite, adding negative 10. So it's the same deal here. Example 3, simplify 7x plus 4y. Well, now, how does it work when you have x's and y's? Yeah, it doesn't work. So this doesn't simplify. We can't combine these two linear terms because they have different variables. So it, doesn't simplify. More examples in the book. 5x plus 4x equals 9x. Sure. Here we have a bunch of linear terms with x. 3x plus 2x minus x, that's like plus negative 1x plus 4x. So just combine the numbers. So it's 3 plus 2 minus 1 plus 4. So 5 minus 1 is 4, plus 4 is 8. So this simplifies down to just 8x. Here we have t's. This last one has y's. The numbers are -2 plus 2/3. So we need a common denominator. Again, -2 over 1. So multiply top and bottom by 3's. So we get -6 over 3 plus 2 over 3. So -6 plus 2 over 3 when you add those two numbers. So that's -4 over 3. And just emphasizing it doesn't work when you have different letters. These don't simplify. Linear terms that do have the same letters, the same variable, are called like terms. Okay, so it's the like terms that you can combine. And yeah, as we saw, if you have something like -4y, it's good to think of that as plus -4y. So for this complicated example here with x's, y's, and t's, so if you want to simplify this, well, first, write everything with addition. Yeah, we know addition is associative and commutative, so you can reorganize. So put the x's together, keep the y's together. So here we have the two x terms. We can combine those. 5x minus plus -11x. That's 5 plus -11. What's that? -6. Combine the y's now. That's -4 plus 3 is -1. -1y or just -y. And the 2t is on its own. So that just gets copied. Alright, so the simplified version looks like this. Okay, so again, the moral is, if you see linear terms like this, so just numbers times variables, you can combine the linear terms that have the same variable. Okay. Okay, so that was just some preliminary algebra. The main topic is linear equations in one variable and trying to solve them. Right, so this section 6.5. If an equation only has linear terms with the same variable on both sides, as well as numbers, then it is a linear equation in one variable. And these are the simplest types of equations. So that's all we're looking at in this chapter. And for example, 3x equals 15. So that's a linear equation. Here's a more complicated one. Negative 2x plus 6x plus 2 is equal to x minus 4. Alright, so just linear terms in the same variable x, and also numbers added or subtracted. So this is an equation now, so that's different from what we've been looking at. It's got a equality symbol. Okay, so yeah, what we were looking at in the previous section. So something like this is not an equation. There's no equality here. It's just a piece of algebra. So this is just an algebraic expression. Same here. But now we're talking about equations, and equations can have solutions. A solution of a linear equation is a number you can substitute for the variable to make the equation true, to make the left side equal the right side. Example 1 is for a solution to this equation, 3x equals 15. How about 5? Well, what happens if we substitute 4 for x? So replacing that x by 4, we get 3 times 4 equals 15. On the left we have 12. 12 equals 15, that's false. So that tells us 4 is not a solution. But yeah, if you put in 5 for x, replace x with 5, then we get a true statement. 15 equals 15. Alright, so 5 is a good number, 4 is a bad number, so 5 is the solution. Yeah, there's only one number that makes this true, it's 5. And notice, yeah, when you're substituting, it's good to use parentheses. So replacing x with 4, write the 4 with parentheses. Example 2 is negative 2, a solution to this to the second equation. Okay, so every x gets replaced with this negative 2. I use parentheses. Okay, so now you have more work to check. So is the left side equal to the right side? Is this a true statement? So this negative 2 out here is multiplying the x, So we're having negative 2 times negative 2, that's 4. Here we have 6 times negative 2, that's negative 12. And here, yeah, minus 4, I changed that to plus negative 4. Okay, so we're adding these sign numbers. Yeah, 4 plus negative 12 is negative 8, and negative 8 plus 2 is negative 6. Negative 2 plus negative 4, add the absolute values, keep the sign, that's negative 6. That's so true. Yeah, so this does work. So negative 2 is a solution. Alright, so yes, so for any linear equation like this, if I give you a number, then it's fairly easy to check if that number is a solution. So just substitute and then use the order of operations, the usual multiplying before adding to work out both sides and see, do we get, is the left side equal the right side? Example here, show that negative 4 is a solution to this equation. Negative 3y equals 12. So replace, yeah, this is an equation in y. So now we're replacing the y with negative 4. On the left, it's negative 3 times negative 4, that's 12. So that's 12 equals 12, that's true. So negative 4 is a solution. Here, next example, show that 10 is not a solution to z minus 9 equals negative 1. So if you replace that z with 10, we're getting 10 minus 9 on the left. So that's 1. Yeah, I don't know why these got switched, but so after the substitution, we're getting 1 equals negative 1, which is false. Okay, so 10 doesn't work, so 10 is not a solution. I guess if you try 8, so 8, then it works. So the solution is 8, just by looking. How about this one with fractions? Show that 3 is a solution to the equation 2 minus 2/3 times t equals 0. But 4 is not. Alright, so we're first replace t with 3. So we have negative 2/3 times 3. So multiplying a fraction by a whole number, so you write that 3 over 1. So 2/3 times 3 over 1. And yeah, the 3's cancel. So that's just negative 2. Or if you like, yeah, multiplying straight across, it's 6 over 3, but that just simplifies to 2. And we have minus, so it's 2 minus 2, 0. So 0 equals 0 is true. So 3 works, so 3 is a solution. Yeah, these linear equations, we're just expecting one solution. So 3 was the solution here. If you try 4, what goes wrong? Well, 2/3 times 4 is 8/3, and 2 minus 8/3. Well, 2 is 6/3, so 6/3 minus 8/3 is negative 2/3. Yeah, that's not equal to 0. So 4 doesn't work. 4 is not a solution. All right, yeah. So in example 2 here, we checked that negative 2 was a solution. And making the point here, we could have simplified the two linear terms on the left. So we know that negative 2x plus 6x simplifies to 4x. Negative 2 plus 6 is 4. Okay, so the original equation simplifies to this slightly simpler version. And we say that this equation here is equivalent to the original. So that means it has the same solutions. Okay, so yeah, we haven't really changed. So this is the original equation. We just simplified these two linear terms. So these are really they're equivalent equations. Yeah, they look different, but the point is, yeah, any numbers, any x's that work for the original are going to work for this, and vice versa. So that's a key idea. So we'll see that any linear equation in X is equivalent to, can be simplified to, one that looks like this: ax plus b equals c, for some numbers a, b, and c, with a not equal to 0. Okay, so what we're saying is, yeah, this complicated looking linear equation, we can do algebra to simplify this to make it look like this. So, and that's our key idea. We want to simplify these linear equations, makes them easier to solve. Alright, so here's a linear equation that looks like this. So instead of a, we have negative 5, b is 1, c is 6. Can we spot the solution to this? So can we see an x that makes this work? So yeah, maybe play around with it, try different numbers. A simple number to try is x equals 0. So if you replace x by 0, well, negative 5 times 0 is 0, so this disappears. But yeah, that doesn't work. So 0 is not a solution. Another simple number to try is 1. Negative 5 times 1 is negative 5, plus 1 is negative 4. Alright, that doesn't work either. But, yeah, how about negative 1? So if you replace x with negative 1, so negative 5 times negative 1 is 5, and 5 plus 1 is 6. So yeah, so here just playing around with some small numbers, some small integers. We see that negative 1 works, so that's the solution here. Yeah, so these linear equations, they always have exactly one solution. Alright, so here we're just kind of guessing what the solution could be. Is there a method? Yeah, so we'll see there's a simple method to find solutions to linear equations. Yeah, so finding solutions, yeah, that's called solving. And there are 2 steps. So step A is to add the same number to both sides. Okay, we'll see what's a good number to use. And then step B is to divide or multiply both sides by the same number. Okay, and the point is, if you add the same thing to both sides of an equation, then you'll end up with an equivalent equation. You don't change the solutions. And the same if you divide both sides of an equation by the same number. Again, you don't change the solutions. Example 4, use step A to solve x minus 5 equals 6. Okay, so what's the number we want to add to both sides? Well, we have x minus 5, so if we're trying to get just x, we'd like to cancel that negative 5. So the right number to use here is plus 5. So add 5 to both sides. Negative 5 plus 5 is 0. So we don't even need to write it. 6 plus 5 is 11. Okay, so we get x equals 11. So that's telling us the solution. Yeah, this is an equation equivalent to the original, but this one makes it clear what x has to be. And you could also double check, yeah, substitute that 11 for x, you'll see, yeah, it does work. Yeah, in this example, we could have added or subtracted any number on both sides, but only this plus 5 gets us, shows us that x has to be 11. How about this one? Use step b, multiplying or dividing, to solve 3x equals 15. Okay, so this time the x is being multiplied by 3. We're looking for, again, we're looking for x, we're looking for 1x. So this time it makes sense to divide both sides by 3. Okay, so 3x divided by x, 3x divided by 3 is, well, 3 over 3 is 1, so this is x. 15 divided by 3 is 5. Okay, we did the same thing to both sides, so this is an equivalent equation. And yeah, now we see the solution, x equals 5. Alright, so these are the two basic steps, A and B, so that's all we need. Yeah, just to point out some common mistakes. Yeah, for that first example, yeah, we see a 6 on the right, so maybe tempting to subtract 6 from both sides. Well, you get this is an equivalent equation, but it's not so useful. So x minus 11 equals 0. Yeah, so the best thing, so a better step is to add 5 to both sides to see that x equals 11. Yeah, another kind of mistake is to use the wrong operation. Yeah, 3x equals 15. Yeah, what happens if you subtract 3 from both sides? Well, yeah, yeah, you get 12 on the right, but 3x minus 3, is that x? No, it's just 3x minus 3. So this is not correct. So you're really just getting 3x minus 3 equals 12, which doesn't help. Alright, so yeah, the correct thing to do here is to divide both sides by 3. Alright, so here's a linear equation with addition and multiplication. Okay, so we always want to do that step A first, adding or subtracting on both sides. Okay, the ultimate goal is to just get x on the left. So first we're going to try to eliminate this 3. So we subtract 3 on both sides. Yeah, it's the same as adding negative 3. And yeah, here's that equality, that's the dividing line, so make sure you're doing the same thing on both sides. So we have minus 3, minus 3. These cancel, that's 0. So 4x is equal to 31 minus 3, that's 28. And now we use step B. So 4x, we're looking for 1x, so divide both sides by 4. So 1x is equal to 7. Okay, so that's our solution. Yes, since it got a bit complicated, let's double check we got that right. So back in the original equation, check that 7, if you substitute x equals 7, you get a true statement. Well, 4 times 7 is 28, plus the 3 is 31. Yeah, so that definitely works. So we can say x equals 7 is the solution. All right, so yeah, that's nice. You can check you got the right answer. And yeah, so what would happen in that example if we use step B first? And so 4x plus 3 equals 31. What happens if you divide both sides by 4 first? Well, yeah, you see, you can't just divide the 4x, you're also dividing the 3. So that doesn't work. You're getting x plus 3 over 4 equals 31 over 4. Yeah, you don't want to include any fractions. Okay, yeah, so the best first step here is to use the A step, adding and subtracting. So get rid of that 3 and then divide by the 4. Example 7, negative 9x plus 4 equals negative 14. So throwing in more negatives. Okay, we do want to get rid of that 4 first, so subtract 4 from both sides. Negative 9x is equal to, okay, so yeah, sign numbers, negative 14 minus 4. That's the same as negative 14 plus negative 4. Add the absolute values, keep the sign, negative 18. Okay, now the number multiplying the x is negative 9, so divide both sides by that number. Negative 9x divided by 9 by negative 9 is 1x. Negative 9 divided by negative 9 is 1. And negative 18 divided by negative 9 is 2. So here, remember, when you're multiplying or dividing two numbers, if they have the same sign, the answer is positive. So negative 9, yeah, that's what we want to divide both sides by. Yeah, it's whatever number's multiplying the x. If you divided both sides by positive 9 instead of negative 9, you'd get negative 1x equals negative 2. That is equivalent, but it's harder to see that x should be 2. So yeah, you could do one more step here, divide both sides by negative 1 to get x. Okay, I don't recommend that, so yeah, just whatever numbers multiplying the x, divide both sides by that exact number using the sign. Okay, so x equals 2. And double check that in the original. So negative 9 times 2 is negative 18, plus 4 is negative 14. Yep. Looks good. All right, so that's how we're solving these simplified linear equations. So if you have ax plus b equals c, the first step is to subtract b from both sides, and then divide both sides by a. So you're just isolating the x. Okay, some more examples in the book. So x minus 3 equals 6. Well, for this one, you would just want to add 3 to both sides. Step A, so x equals 9. Okay, so 9 is the solution. And yeah, here's a more awkward one. 9 is equal to negative 1/5 times z. All right, but yeah, this time the variable's on the right, but it's the same idea. We'd like to get just z on the right. Well, the quickest way to do that, so what we'd like to multiply both sides by the same number. How can you get 1z? Well, if you multiply negative 1/5 by negative 5, it's reciprocal. So negative times a negative is positive. And we get 5 on the top, 5 on the bottom, so that's 1. All right, so the best thing to do for this equation is multiply both sides by negative 5. Negative 5 times 9 is negative 45. So that's z, that's the solution we're looking for. Another way to think of it is, the number multiplying the z is negative 1/5. So we could divide both sides by negative 1/5. But dividing by negative 1/5 is the same as multiplying by 5, the reciprocal. All right, so either way we get negative 45, and you can check that works. 9 equals 9, that's true. Okay, again, here are the two steps. So adding the same number to both sides, or multiplying both sides by the same non-zero number. We can also subtract and divide. Okay, how about one last example? 229. Solve the equation 2x plus 4 equals negative 10. And check the solution is correct. Okay, so we have x's on the left this time. The first step is to remove this 4, so subtract 4 from both sides, or add negative 4 on both sides. Okay, so negative 10 plus negative 4 is negative 14. That's equal to 2x. We're looking for 1x, so divide both sides by 2. Negative 14 divided by 2 is negative 7. All right, so that's our solution. Negative 7. Let's check it's correct, see if we've made a mistake. So substitute negative 7 for x in the original equation. So it's 2 times negative 7 plus 2 plus 4. Is that equal to negative 10? Yeah, we can write it with a question mark. Well, on the left we have, so working out the left, yeah, it's multiplication before addition. So that's negative 14 plus 4. And yeah, that is negative 10. So that worked. So that's our solution checked out. So x equals negative 7. Alright, so that's our introduction to linear equations. We'll see more complicated versions next.